This video is about WinMate ATX power supply. It's a 130 watt fanless power supply and can be used on any computer, of course, if the computer doesn't require more than 130 watt. And since this video is a bit long, I made some buttons on top of this video so you can jump to different parts in this video. This is the main DC input connector, and if you don't want to use this one, you can use this other one, the white one. It's a P4 connector. It's the same thing. This is the CPU power input connector, a Molex connector, and a 20-pin ATX connector that will work with any 24-pin motherboard. I will explain later why. This is the minus 12 volt DC-DC converter. This is the IC for the 12 volt DC-DC converter. This is the input filter. You have two capacitors and the coil. The main coil for the 12 volt DC-DC converter. These are the output capacitor, three 1000 microfarad capacitors. This one is the main IC for the 5 volt. This one is the coil for the 5 volt standby and the IC for the 5 volt standby power supply. These are input filters for 3.3 volt and 5 volt. These are the coils, the main coils for 5 volt and 3.3 volt. This is the main IC for the 3.3 volt. It's the same one as for the 5 volt. I should mention before I forget that this is a 4-layer PCB. You normally don't see 4-layer PCB on power supplies, but since this was designed for industrial application, probably cost was not as important as electromagnetic immunity and emission. These two are the MOSFETs for the 12 volt DC-DC converter. And these other two are for the 5 volt DC converter. And these two are for the 3.3 volt. The layout, as you can see, it's really well made. The components are placed close to the right connector and everything is really well done. Of course, it's a 4-layer PCB, but still this is really well designed. You see, this is the 5 volt trace, and this one is the 12 volt. You see the connections to the Molex and the ATX connector. I will show you how you can test this power supply without being connected to a computer. This is the 5 volt standby. This should be the 12 volt, but it's not because the power supply is in standby. In order to power on this power supply, you will need to connect the power on pin to ground. As you can see, I just did that, and you have the 12 volt now on the ATX connector. This is the main 5 volt. It's not the same with the standby 5 volt. This is the 3.3 volt. And this is the minus 12 volt, but this is almost obsolete. If you don't have a RS-232 on your computer, it's probably not used. And if I disconnect, then I get back into standby. This is the AC adapter that I use in this video. It's a 20 volt, 6 amps, 120 watt. And as you can see, it doesn't look too bad inside. It's not the best AC adapter I've seen, but it's not bad. It seems to have quality components inside and seems to be well built. I will do some additional tests using this 100 watt light bulb and this 750 watt inverter. So I convert 12 volt in 120 volt for the light bulb. Now, as you can see, power consumption on 12 volt line, it's 9.7 amps, about 9.7 amps. And as you can see, powering on and off the inverter doesn't make too much influence on the 12 volt output. You see it's 12.23 volt. Almost the same with load or without a load. Now I will add a 5 watt LED light bulb, so the current will exceed a little bit 10 amps, it's 10.1 amps right now, and like you see, voltage it's still fine, it's 12.2. It dropped about 20 millivolt, but this is not significant. This is because it's close to the 10 amp limit of the power supply. I will test now the overcurrent protection on 3.3 volt output, and as you can see, if I short circuit the 3.3 volt, power supply will power down completely. Now I powered on again, and you see again overcurrent protection works. This is an efficiency test for the 12 volt DC-DC converter, and at the input you see 2.6 amps, at 20 volts it's about 52 watt, and on the output we see the voltage is 12.25 and the current 3.95 amps, so 48.38 watt. And if you calculate, you will get about 93% efficient. As an example, I used my computer in 4 different configurations to show what kind of power consumption you can expect. And this first configuration, the CPU is running at nominal frequency and voltage. And the board is using the integrated graphic card. The entire boot sequence is included, even if it's long and boring, at least on the first test, so you can see what kind of power consumption you get during boot. There will be a variation in power consumption, but it will not exceed the maximum current that you will get during the benchmarks. Okay, finally. As you can see, at idle we get about 2.1 amps, and multiplying this by 19.42 we get just a bit over 40 watt. And the first benchmark is a ray tracing benchmark, and we get about 3.45 amps at peak, and this is just about 67 watt. And the other benchmark is Blowfish benchmark, and with this we get a peak current of 3.91 amps. That's 76 watts, just quite a bit more than the other benchmark, and you will see in the later test that there will be almost no difference. Now this next one, it's the same hardware configuration, just that I modified the CPU clock and voltage. I will use the 6-time multiplier, so it will run at 2 GHz, and I will reduce the voltage to 0.9375 volt. Now this time with the CPU undervolted and underclocked, we get an idle current of 1.95, and this is just a bit under 38 watt. And don't forget, this includes the ATX power supply losses, so the actual computer uses less than 38 watt. And this is the first benchmark, the Blowfish benchmark, and we get a current of 2.71 amps. That's about 52.6 watt. And with this ray tracing benchmark, we get 2.74 amps. That's about 53 watt. And you see that now difference between these two benchmarks in power consumption, it's quite small, almost inexistent. In these first two tests I used this silicon image DVI adapter so that I can use my integrated graphic card with a DVI monitor, since my motherboard only has VGA. And now in the next two tests I will use this HD 4650. So this will use quite a bit more power than the integrated graphic card. Now this one is the third configuration. I will still use the CPU undervolted and underclocked, but this time I will use a dedicated graphic card, HD 4650, like I said. Okay. Now this configuration at idle, it's using 2.65 amps. That's about 51.5 watt. And with a blowfish benchmark, it's using 3.4 amps. That's about 66 watt. And with a second test, with a ray tracing test, it's using 3.34 amps, so that's almost 65 watt. Now, since I installed a dedicated graphic card, I will also test the power consumption using a racing game. This is a Linux game, Torx. And you will see that maximum current during this game will be 3.88 amps. That's about 75 watt. That's the highest power consumption up to now. I also used Blender 3D to measure the power consumption, since this program uses OpenGL to draw in the viewport, and power consumption is about 68 watt. So this is a bit less than the game. This last configuration is the same as the one before, just that the CPU will be at nominal frequency and voltage. The idle power consumption is about 52.4 watt. And blowfish test gives about 91 watt. As you can see, 4.72 amps. The second test, the ray tracing test, uses about 82.1 watt. So quite a bit less than the first one. Now I forgot about the game, but the OpenGL test with Blender 3D is using about 3.49 amps at most, so this is just under 68 watt. As you can see, 3.49 maximum. Probably the most asked question is if a 20-pin power supply will work with a 24-pin motherboard. And the answer is yes, definitely. The additional 4 pins are just redundant and will only make sense if the power supply is more than 400 watts, or actually if the computer uses that much power. Another frequent question is, what's the polarity for the input mini-DIN power connector? And as you can see in the image, the upper pins are positive and the lower pins are negative or ground. And if you don't like to use this connector, there is another possibility. You can use the P4, the white connector that is just in the back of this mini-DIN connector. And as you can see, the polarity is the same. The upper pins are positive and the lower pins are negative or ground. And you can use this together with an extension cable, and on the other end you can use any type of connector you wish. Another question is, will this power supply work with my computer? And the answer for this question is not that easy. It depends on a lot of factors, but basically if you have a mini ITX or ATX motherboard and a CPU that doesn't exceed 65 watt TDP, it will probably work. You can also add 1 or 2 hard drives for a 65 watt TDP CPU. And with lower power CPUs like the Atom or the low power AMD Fusion, you probably could use even 4 hard drives, or even SSD and 4 hard drives, or different combination like this. The biggest in power consumption is the GPU, especially if it's a dedicated GPU. So dedicated GPU can use 2 times as much as this power supply can deliver, so it will not work in most cases with a dedicated GPU, except with a very low power GPUs like those under 20 watt or something like that. I can answer more precisely this question if I know what motherboard, CPU, how much RAM, and how many hard drives you have, and what type of hard drives. Also, if you want to use or not a dedicated GPU, and what kind of GPU are you thinking about. If I have all this information, I could give you an estimate on power consumption and let you know if this power supply will work or not with your configuration. So if you have this kind of question, you can leave a comment and I will answer your question. Last question I will answer in this video is if this power supply works from 18 to 28 volt. And as you can see, it doesn't work at 16 volt, but it will start working at around 17 volt. So, as you can see, it works at 70 volt, but I don't recommend because it's too close to the limit. The best will be to use something around 19-20 volt because it will be far from lower limit and it will be more efficient at higher voltages like 28 or 24. Of course it works at 24. It will also work at 28 and even 30 volt, but I will not recommend going over 28 volt. Before I end this long video, I want to say that correct pronunciation for my username is Electrodacus. A lot of people have problems with this, but yeah, it's not that important. And if you have any questions about this video, please leave a comment and I will answer.